Okay, today we want to talk about how to write formulas for ionic compounds. All right, so the first thing that we need to know how to do is know the charges for both the cation and the anion. I want you to know that the cation is the first name. Remember, cation is positive. Cation is the first name. And the anion is going to be the second name or the last name. Okay. The first name is going to have a positive charge. It's a cation. And if there's a Roman numeral, that's the charge of the cation. The second name, there's a couple things that you should know about the second name. First of all, if it ends in "ide," it's probably, not always, there are two exceptions, but it's probably a monatomic nonmetal anion. It's a monatomic, and you could say it's a nonmetal. So you just know where to find it on the periodic table. It's going to be in that nonmetal section, and it's just an atom that the ending has been changed to "ide." If it ends in "ate" or "ite," if it ends in "ate" or "ite," it's a polyatomic. And you'll want to check the periodic table for that. Or not the periodic table. You'll want to check that chart, the polyatomic ion chart, for that. So let's look down here and do some examples. The first one is magnesium sulfide. Magnesium is Mg. So it's Mg, and we want to find the charge. So if I want the cation symbol, I need to find its charge. So let's look at the periodic table and figure out what its charge would be. Magnesium is right here in group 2A. That means it's got a positive 2 charge. Magnesium plus 2. All right, and then I have sulfide. Well, it ends in "ide. That means it's probably a monatomic nonmetal anion. So what starts with sulf that's a nonmetal? Well, that would be sulfur. So I just need to find sulfur on the periodic table and see where that's at. Sulfur is right here, and it's in group 6A, 16, which is 6A. It's got a negative 2 charge. That's something to memorize. And if you need another way to remember that, it's 2 steps away from the noble gases. So -1 is group 1A, or group 7A. You go one more step, it's -2. Go one more step, it would be -3. One more step would be -4 for carbide. Okay, so 4, 3, 2, 1. Counting from carbon, 4, 3, 2, 1. Those are our negative charges. Or if you're counting from the noble gases are 0, and these are negative charges. So 0, then -1, -2, -3, -4. Anyway, sulfur has a -2 charge, and that's what we're looking for. S with a -2 charge. Well, if I have a positive 2 and a -2 charge, you can maybe see right away that those cancel each other out. They make each other neutral without me having to do anything else. So my formula is going to be MgS. But if you didn't recognize that, if you didn't see that, and you went ahead and did the crisscross, just don't forget to reduce. If I crisscross these, I'd put my 2 here, and I'd put another 2 down here. I need to reduce it now. So the 2-to-2 ratio would be reduced to be 1-to-1, which means it's just MgS. Let's go to the next one. And by the way, if you're catching on, if you get the hang of this, try the next one, pause the video, and see if you get the same answer that I do. Zinc nitride, Zn, and nitride, it ends in "ide," so that sounds to me like let's see, what starts with nit in ITR that's a nonmetal? Okay, that would be nitrogen, which is capital N. So I'm going to find Zn and N, and I'm going to try to figure out what their charges are. Looking at our periodic table, Zn is right here, zinc. Okay, now that's one of those three that I wanted to memorize the charges of over in that section of the periodic table. You see our staircase here, Ag, silver is at the bottom, then zinc, and then aluminum, positive 1, 2, 3. So zinc has a positive 2 charge, and then nitrogen was the other one over here, has a negative 1, negative 2, negative 3. It's in this group. It's got a negative 3 charge. So I have positive 2, negative 3. Zinc, positive 2. Nitride, negative 3. Okay, let's crisscross. So move our 3 down here. Move our 2 over here. Can I reduce those? 3 and 2? There's no way to reduce 3 and 2, so we're just going to leave that alone and get rid of our charges. So it's going to be Zn 3, N 2. Just don't forget to always check and make sure that it's reduced. All right, gold 1 nitride. Well, I don't know the... Gold is one of those that we don't actually know the charge of, but they told us the charge by giving us a Roman numeral. So that means this is gold, which if you don't know the symbol for gold, it's AU. You might want to memorize that one, AU, with a +1 charge. And then nitride, well, we just found nitride. It's negative 3 in with a negative 3 charge. Let's do our crisscross. 1 goes down here. We don't have to write the 1. 3 goes over here. So it's AU 3N. Tin 4 sulfide. Tin, by the way, is SN, another one that might be helpful to memorize just because it's not what you would think. And then sulfide, sulfide, what starts with sulfur, S, and we actually did that up here. We found sulfide earlier to be negative 2. So we could say SN, and it says it's a positive 4 charge. And then sulfide, that's S with a negative 2 charge. Let's crisscross. Put a 2 down here. Put a 4 over here. Check and see if you can reduce it. Can I reduce a 2 to 4 ratio? I hope you recognize if I were to make this a fraction and say 2/4, you would immediately say, you need to reduce it to 1/2. It's kind of the same concept. Can I reduce a 2 and 4? I can. I can reduce it to SN1 and S2. Divide both of those numbers by 2 and you get a reduced form of SnS2. Potassium hydroxide. Potassium is K. It's another one of those that's kind of weird. Maybe you wouldn't have thought of that. And then hydroxide, that's one of them I wanted you to memorize because that X is nowhere in hydrogen. A lot of students say hydroxide must be H with a negative charge. That's not right. Hydroxide is a polyatomic ion. So we want to go back to our polyatomic ion chart, which you can click up here and find it. I've got it open in this tab over here. Hydroxide, so you just look through these until you find hydroxide. There it is. Hydroxide is OH with a minus charge. OH with a -1 charge to be exact. If it just says minus, that means -1. So OH is what hydroxide is with a minus charge. So I have K. We didn't find it on the periodic table. I ought to do that real quick. K is right here in group 1, so it's +1. And then we said hydroxide has a -1 charge. K has a +1 charge. OH has a -1 charge. So we have a 1 and a 1, and we really don't need to write the 1s in chemistry. By the way, if you did have a subscript, you need to have parentheses around your polyatomics if you end up with more than one of them. But this time it's just one of them, so we can write KOH, and that is it. That's our formula. Ammonium sulfite. Ammonium sulfite. This is another one we want to memorize. Ammonium is not an element. Ammonium is our only positive polyatomic ion. It's NH4 with a positive 1 charge. You can find it on here. It's up here, ammonium. But I want you to try to memorize it so that you don't waste time looking for it on the periodic table. Ammonium, and then the other one was sulfite. It's very important that you pay attention to the ending of the names because some of them are very similar names. Sulfide, sulfate, sulfite, they're actually different. So we've got to find sulfite with an ITE at the end. Sulfite. Well, I see it right here. Sulfite. It's right next to sulfate and thiosulfate. There's lots of names that sound similar. This one is sulfite, and it's SO3 with a -2 charge. SO3, let's put that all in parentheses. It's got a -2 charge. And then we have NH4 in parentheses with a positive 1 charge. Crisscross, I'm going to have a 1 over here and a 2 over here. That makes it NH4 2 SO3. And then gold 3 bromate. Gold 3, that tells me it's AU with a positive 3 charge. And then bromate, not bromide, not bromite, bromate. If it ends in 8, I'm probably going to check my polyatomic ion list. Bromate. And actually this is one, yeah, there it is. Bromate is BrO3 with a -1 charge. Put the 1 here, put that 3, crisscross it, and put it down here. AU, BrO3, 3. All right, before I move on to do the last few, I want to make a point right here because I want to make sure that you understand why we have the subscripts we do. Why are we doing this whole crisscross thing? It's just a quick trick to make it all neutral, to make it balance out. And here's what I mean. If I have one atom that has a positive 3 charge, that's an overall charge of positive 3. If I have 3 atoms of a -1 charge, that's an overall charge of -1. I'm looking at gold 3 bromate as our example. So if I have a positive 3 and a -3 and you add them together, you get 0. So when you do the crisscross, it makes that happen. You just have to make sure you reduce. Like our example up here, tin 4 sulfide. If I'm looking at this example, 2 times positive 4 is positive 8. 4 times -2 is -8. So positive 8 and -8 add together to be 0. That's a neutral compound. But we want to simplify it as much as we can and make sure that we have the smallest ratio possible. So we simplified our ratio to be, instead of 2 to 4, 1 to 2. It's still true though. If I take 1 times 4, 1 times positive 4, so we reduce this to 1 and 2, right? 1 times positive 4 is positive 4. 2 times -2 is -4. If you add positive 4 and -4, you get 0. That's the whole goal of this, because every ionic compound is neutral. So to represent it accurately when we write it on paper, we have to do a little bit of math or do the crisscross and then reduce. But we're doing a little bit of math to show that we have a neutral compound where the positives and negatives cancel each other out and we have a neutral zero charged compound. Okay, let's do a few more names. This time we don't have that middle step, so some of you guys can jump straight to the formula because you're getting really good at doing this and you can do some of them even in your head. I'm going to do the work over on the right hand side and then we'll write the formula in the box. Rubidium oxide. So rubidium is Rb. Rubidium is Rb. Oxide, okay, it ends in ide, and it's not cyanide or hydroxide. Those are the two that I've got to memorize, and remember, they're not monatomic. Those are the polyatomics. So oxide, what starts with ox that's a non-metal? Well, that would be oxygen. So I have Rb and I have O. Now we just need to look up their charges. Rb and O. Find it on the periodic table because they're both just monatomic elements. Rb is in group 1a, so it's got a positive 1 charge. Oxide, oxygen, is in group 6a, which makes it a negative 2 charge. Remember, this is 0, negative 1, negative 2. So positive 1, negative 2. Rb is positive 1. O is negative 2. Our shortcut is crisscross and reduce. So that would be 2, 1. I can't reduce 2 and 1 any farther. So it's just Rb, 2, O. And we don't write O's as, we don't write 1s as subscripts. Copper 2 oxide. Well, I don't have to look up oxide again because I just did it. Oxide has a negative 2 charge. Copper 2, that's just copper with a positive 2 charge, and if you already know the charge, or if you already know the symbol of copper, it's Cu. If not, you could find it on the periodic table. Cu, and it's got a positive 2 charge. Positive 2 and negative 2 already cancel each other out, so I really don't need to do anything else. It's just CuO. That's the easiest way to do it. If you forget about that, crisscross and reduce. 2, 2, and then you can reduce that 2 to 2 ratio to be a 1 to 1 ratio because they cancel out. Then we have ammonium phosphide. Ammonium phosphide. Ammonium is that one that is a polyatomic ion. We see it up here. It's NH4+. I'm going to show my work down a little bit farther because I'm running out of space. NH4 plus 1. And then phosphide, let's see, ide means probably on the periodic table. It's just a nonmetal. What's the nonmetal that starts with phos? It'd be phosphorus. So let's find phosphorus. Phosphorus is P. And it's got a negative 1, negative 2, negative 3 charge. P with a negative 3 charge. Crisscross, I have a 3 down here, and I have a 1 down here. So NH43P. Ammonium phosphide. Then strontium carbide. Strontium, we found it a little while ago, I think. No, we didn't. Okay. Strontium, that's going to be a metal, and then carbide, ide, so that means it's probably a nonmetal. What's a nonmetal that starts with carb? That would be carbon. Okay, so I'm looking for Rb, which is in group 1. No, I'm not. I'm sorry. I'm looking for Sr, strontium. So I'm looking for strontium, which has a positive 2 charge because it's in group 2a. Strontium, and it was carbide, so carbon, which has a negative 4 charge. We have 0, negative 1, negative 2, negative 3, negative 4 for carbide. So Sr is positive 2, carbide is negative 4. Sr is positive 2. Carbide is negative 4. So crisscross, we have a 4 down here. We have a 2 down here, but we need to reduce. They can be reduced to 2 and 1. 2 and 1, so Sr2C. And then finally, silver chromate. Silver is Ag. Chromate, 8. Sounds like I need to look at my polyatomic ion list. So chromate. Let's look here. Chromate. There it is. CrO4 with a negative 2 charge. CrO4 with a negative 2 charge. And we got to find the charge for silver. If you don't have it memorized, look at the periodic table and you can remember it's right here. Remember that it's in that staircase. Silver, zinc, aluminum. So positive 1, positive 2, positive 3. Silver is positive 1. Crisscross, we end up with the 2 going to silver and the 1 going to chromate. So Ag2CrO4. With or without parentheses, as long as you don't have more than one polyatomic ion. All right, that's it for naming or for writing formulas. You ought to be able to finish up the formula writing practice at this point.